Please pause the video and try this question.
All right. A school administrator will assign each student in a group of n students to one of m classrooms. What's going on here? Anyway, one thing I can recommend, or what I do anyway, is that whenever I come across variables in the question, first I'm thinking not about the variable, but just what they're talking about here. So assign each student in a group of certain students to one of certain classrooms. That's what I have here. Sure. So there's a school admin, there are a bunch of students, there are a bunch of classrooms, and that guy will assign each student out of those students into classrooms. Each student into one. Okay, now I need to be clear about which variable is which. So M is the classrooms, N is the students. One thing that, in fact, I noticed, classrooms, M, students, N, right? So those are the variables also. That way, it's very easy for me to get confused. I know which one was students, which one was classrooms. So here I got a hack that would help me. Worst case, I could just write it. Or just rooms, right? Don't need to write the entire thing. Basically, things that I know I can get confused about, I would rather take steps to fix them beforehand only, to address them even before they become an issue. If 3 is less than m, less than 13, less than n. Okay. Number of classrooms is between 3 and 13, not inclusive. Number of students is more than 30. That makes sense. A school that has more classrooms than students would be a very weird school, right? Typically, schools have more students, fewer classrooms. That makes sense. Okay. I have some specific restrictions between 3 and 13, more than 13 and all that. Okay. If that's the case, is it possible to assign each of the n students to one of the m classrooms? Assign each of the students to one of the classrooms so that each classroom has the same number of students assigned to it. Is this whole thing possible? Given that m is between 3 and 13, not inclusive, n is more than 13, is this thing possible? Is what thing possible? That they can assign each of the students to one classroom in such a way that there are equal students in every classroom. Let's spend some more time to make sure we understand what's going on here. Right? This whole bit about each of the n students to one of the classrooms and same number. What does that even mean? So I'm just starting with some numbers. Let's say overall there are 20 students, and let's say there are 4 classrooms. So can I assign 20 students into 4 classrooms in such a way that each one has equal students? Actually, yes. 5, 5, 5, 5. This is already giving me an idea. Basically, can I divide the students equally in 4 classrooms? That was the problem statement here. So if 20 is divisible by 4, then things are working out. I take another example, 18, for example. Let's say 18 students and same 4 classrooms. Can 18 students be spread across 4 classrooms as that each one has equal students? Well, even if I give 4, 4, 4 for each, I'm left with 2. I would cut up the people into halves. So 2 classrooms, at least 1 or 2 classrooms will get more students than the others. All right. So essentially, the question boils down to, is the number of students a multiple of the number of classes? Right? This weird complex language. Is it possible? Why are they using that language? Is it possible? Well, because maybe, for example, in my school in class 11th, students used to join different sections based on their choices: commerce, science with eco, science with this, science with that, and all that. Right? So it's not like each section had the same number of students. That depended on choices. But then we could ask the question, is it possible to assign each student to a classroom such that each class has equal students? That we could ask. Is it possible or not? Whether the school does it or not is a different matter. Right now, they're just asking me, is it even possible? So that's why that language is there. I hope it didn't throw you off. Is it possible? And then, if the number of students is a multiple of number of classrooms, then it is possible. For example, 20 and 4, 20 and 5, 20 and 2, 20 and 10. If the number of students is not a multiple of the number of classes, then we can't divide them equally. So 18 and 4 as an example. Okay. So the question essentially is n a multiple of n? Did you guys reach till this point, till this understanding with the question? Is it clear now, Kunal? If you have any question, let me know right now. Okay. All right. Now into the statements. Statement 1. Very similar language, actually, very similar to the question. It is possible. Now, no longer a question. It's a given piece of information. it's possible to assign each of 3n students. What the hell's going on here? 3n students? How come suddenly they have 3 times the students? Well, they don't have 3 times the students. They're just saying it is possible to assign 3 times the students to one of the classrooms such that each classroom has the same number of students. Essentially, in mathematical terms now, the statement is telling me that 3n is a multiple of m. 3n is a multiple of m. The question is n a multiple of m? That's what we have to figure out. Okay, let's stay here. We'll start off with some valid value and then see where that leads us. So n is more than 13. I'm thinking 3 times 15, for example, chalo, is a multiple of m. M is between 3 and 13. So 3 is not included. M, I'm thinking, can be 5, for example. M can be 5. And then in this case, is n a multiple of m? I get a yes answer. Okay. So I've got a yes answer at least. Now I'm thinking I have to try to get a no answer. Now, what does that mean, getting a no answer? That 3n has to be a multiple of m. Statement 1 has to be accepted only. But I want to try to get a value such that n is not a multiple of m. 3n is, n is not. The original number was not a multiple, but after bringing 3 into the mix, then it becomes a multiple. Why would, and when would that happen? When basically the denominator is getting cancelled with 3 also. Right? The denominator couldn't get cancelled with n, at least that 3 couldn't get cancelled, but that 3 is getting cancelled with this 3n wala 3. Okay, so that leads me to understand that the denominator should be a multiple of 3 at least. So now, to start off, I'm thinking of the same example only and focusing just on the denominator. The denominator, now I'm thinking I want to try to make a multiple of 3. 3 is too small, rejected. 6, nahi yaar, 3 into 15 upon 6. That doesn't work. I have a 2 left in the denominator. Oh, so 1 3 should get cancelled with this new 3. And if there are any other factors, those factors need to get cancelled with 15. Nice. So I'm thinking now, 3 times 3, 3 times 3, 9. Actually, that's a good value. Because 1 3 will get cancelled with the new 3 and 1 3 will get cancelled with the 3 inside 15. Ah, yes. So now, why is this a good value? Because 3n upon m is indeed an integer. 3n is indeed a multiple of m, but 15 is not a multiple of 9. Perfect. This is exactly what I was looking for. Right? Therefore, statement 1 alone, not sufficient. I could reach here using other values also. Right? Maybe some values which are simpler. The key was, though, to understand that I started with some values, got one answer, and then I started focusing more on what kind of values do I need. Right? So the values that I tried gave me a yes answer. So that's why then I focused my energy later on how to get a no answer. What does a no answer even mean? 3n should be a multiple, but n should not be a multiple of n. When would that happen? N is not getting completely cancelled with m, but when a 3 comes in, then the denominator cancels to 1. That means the denominator is definitely getting cancelled with 3 also. That was the first realization. Then I started thinking in terms of multiples of 3. Then I also realized that the denominator should have some factors in common with the new 3 and some factors in common with n. So that's how I came up with, in this case, 3 times 15 by 9. Statement 1, not sufficient. Statement 2 now. It is possible to assign each of 13n students to one of m classrooms. So 13n is a multiple of n. That's what I have now. So again, let me start off with some values and see where that leads me. So 13 into, again, I'm going to take 15 and 5, in fact. Right? In this case, I get a yes answer. 5 gets completely cancelled with 15. So yeah, in this case, 15 is a multiple of 5. I have a yes value. Now I'm thinking I have to try to get a no value. What does a no value mean? 13n should be a multiple of m, but n should not be a multiple. In other words, that m in the denominator should not get completely cancelled with n, but after 13 comes in, then the denominator should get completely cancelled. Which tells me that the denominator needs to be a multiple of 13. Right? The denominator needs to get cancelled only after the 13 is brought in, not before that. That means the denominator is getting cancelled with 13. That means the denominator is a multiple of 13. Hold on, what is the denominator? Number of classrooms, m, which is less than 13. So the denominator cannot be a multiple of 13. 13 is a prime number. All the multiples of 13 are greater than equal to 13 only, not less than 13. And anyway, it doesn't make sense for any number. Which tells me which tells me there is no way that the denominator will cancel with 13. Therefore, I can't come up with a single value such that I get a no answer. This is not possible. I was trying to figure out a no value. While doing that, I realized, hold on, to get a no answer, the denominator should not get completely cancelled with n, but it should, after 13 comes in, then it should get completely cancelled. That means the denominator should cancel with 13. That means the denominator should be a multiple of 13. But wait, that can't be true. So, not possible. Therefore, if 13n is a multiple of m, definitely n will be a multiple of m. So second statement is sufficient. The answer is B. Now, I could have dealt with the second statement differently also. Let me explain one more way of dealing with the second statement. Although I like this way better, but still, let's say all this didn't strike you. Just focus on this portion on the right. So one side I figured out, then when I'm thinking about the no case. So now, given that m is between 3 and 13, I'm thinking, so let me start with 4, 5, 6, 7, 8, 9, 10, 11, 12, and see what's going on. Maybe I get some idea. So 13 times n upon 4 is an integer. That is, let's say, what if m were 4, I'm thinking. This is an integer. But for this whole thing to be an integer, n by 4 would need to be an integer, because 4 is not getting cancelled with 13. Right? But then that again means that the answer is yes. We're looking for a no case. N should not be a multiple of m for the no answer. Realize 13 times n upon 5, same idea again. 5 will not cancel with 13. That means n by 5 is an integer. 6 will not cancel with 13. 7 will not cancel with 13. 8, 9, 10, 11, 12 will not cancel with 13. That way also you can realize that was for these given values of possible values of m, there is no way that 13n is a multiple, but n is not a multiple. That's just not going to happen. Let me explain one more thing, and then if you have any questions, we'll discuss. Now, the question now becomes, let's say you figured this out or you understood, you followed me till here. Now, let's wonder about how come two statements which are so similar to each other, so similar, the only difference is 13n versus 3n, they're both prime. How come two statements which are so very similar to each other don't have the same result? How come one is sufficient, one is not sufficient? What's going on here? That's the stage I'm at right now. Well, obviously the difference is 3 and 13. They're both prime, but what else is at play here apart from just them being prime or not? Is it just a matter of them being prime? Prime, certainly not. Otherwise, they both would have had the same result. So there is something else going on here. And then I'm thinking about, okay, why could the m, the denominator, not cancel with 13 in the second statement? Why could the denominator not cancel with 13? Because the denominator was less than 13, boss. There is no way it could cancel with 13. Could the denominator cancel with 3? Yeah, there are a lot of factors of 3 between 3 and 13. But there are no factors of 13 between 3 and 13. Because of the range, things worked out this way. Had the range been bigger, had the range been 3 less than m, less than 14, less than n, then I couldn't have been certain. Because then 13 would have been included in the range. And then that 13 could have cancelled with the 13 in the numerator. Things worked out this way specifically because of this range. All right. So what we had here was prime number times a upon b is an integer. And according to the second statement, we knew that the denominator is not a multiple of the prime number. That means that the other term in the numerator must be a multiple of the denominator. Otherwise, there's no way that the b will get cancelled. That means a upon b, an integer. Right? Given this piece of information, that's exactly what's happening in the second one. This is not what happened in the first one. The factors of 3 in the middle, 6, 9, 12, which could cancel with the additional 3. Ab batao, the whole question, ACUC. Now, let me also, I don't usually do this, but let me also mention a test-taking tactic here. See, if your objective is to score really well, and if you are comfortable with scoring anything less than 800, even 790, which is an insanely high score. If your objective, if you're okay, even if you score less than 800, as long as it's a high score, realize that means you are okay to make mistakes. You've given yourself permission. It's okay here. And that's not a bad thing. That's not a bad thing. Your objective is not to answer each and every question correctly. Your objective is to maximize your overall score on the exam. Why I'm saying all this? For a question like this one, pretty intense question. First, just the language itself, pretty heavy. Just to understand what's going on, what's given, what's asked. All that is pretty heavy. Even once we figure all that out, okay, is n a multiple of m? It's not like then the question becomes a piece of cake. Even to figure out whether the statements are sufficient or not, that itself is also very time consuming. Right? So depending on what stage you are at in your test, depending on how you are doing on speed and all that, you could very consciously take a call. This one looks too dense. I am probably going to definitely spend more than 2 minutes on it, probably going to spend 3 minutes plus also. Even then, I'm not sure whether I'll get the right answer or not. Might as well just make a smart guess and move on and maybe save a minute and a half or so. That could be a call you take. Right? So for every question, official question, the question to ask yourself is not how do I fit this into 2 minutes? Not for every question. For some questions, you might need to ask yourself, how do I realize that this is going to be an extremely time-consuming question? And therefore, obviously, depending on your situation, therefore, I might decide to guess and move on to save time. That's another thing that you should be developing. Those calls you should be able to take.